Hi guys, welcome back. Today we will be having the application of the Black-Scholes option pricing model. Remember that the formula of the Black-Scholes model is as follows. Recall that, like the binomial model, we would arrive at the value of the call option by deducting the value of the stock from the value of the portfolio. Take note, however, that the signs are inverted. This is because we are looking at things from the perspective of the buyer of the call option. Furthermore, the terms D sub 1 and D sub 2 are to be calculated as well. Hence, there would be additional formulae to be utilized. Though this seems overwhelming, well, yes, it is overwhelming, the very same principles of binomial model are to be utilized here in the Black-Scholes model. For the model to work, however, we need to make the following assumptions. First, the underlying stock pays no dividend. Only capital appreciation will be the means by which the stockholder would earn. No transaction costs on stocks and options. Risk-free rate is constant. It does not change within the period. Fractions of a stock can be bought or sold. We did the same in the binomial model in the last video. Short selling is permitted. The option is exercisable only at expiry date. We call these European options. European options are to be distinguished from American options because American options can be exercised anytime before the expiry. So we're going to assume European options are to be analyzed. Then lastly, trading takes place continuously. That is, the stock price moves randomly. So the Black-Scholes model formula is as follows. V sub CO is equal to P times N of D sub 1 minus X times E to the power of negative R sub RF times T multiplied by the N of D sub 2. To arrive at D sub 1, we have the ln of P over X plus R sub RF plus sigma squared divided by 2 times T all over sigma times the square root of T. Meanwhile, D sub 2 is equal to D sub 1 minus sigma times the square root of T, where V sub CO is the value of the call option, P is the underlying stock price, N of D sub X is the probability that a deviation less than D sub X will occur in a normal distribution. X is the strike or exercise price of the option. E is the Euler's number, the continuous compounding constant. R sub RF is the risk-free rate of return. T is the time period of the option in years. Ln of P over X is the natural logarithm of P over X. Sigma is the variance of the rate of return on the stock. Let us refer to the following sample case for a demonstration on how to use the Black-Scholes model. DEF company's stock price is currently 20 pesos. A 6-month call option on DEF stock has an exercise price of 17 pesos and has a standard deviation of 40%. The risk-free rate of return is 4%. Determine the value of the option using the Black-Scholes option pricing model. So again, this is the formula of the Black-Scholes model, D sub 1. Plugging in the figures from the sample case, we have D sub 1 is equal to ln of 20 over 17 plus 0.04 plus 0.40 squared over 2 times 0.50 years divided by 0.40 times the square root of 0.50. If we are going to do this, we would have a D sub 1 of 0.7867. If we want to arrive at the n of D sub 1, we have to refer to a Z table or the standard normal distribution table. If you're going to look for 0.79, you would arrive at 0.2852. Then do not forget to add the entirety of the negative side of the bell curve. That's 0.5000. N of D sub 1 is equal to 0.7852. To arrive at D sub 2, we have D sub 2 is equal to D sub 1 minus sigma times the square root of t. D sub 2 therefore is equal to 0.7867 minus 0.40 times the square root of 0.50. D sub 2 would be equal to 0.5039. Using the same table, we would arrive at the n of D sub 2, 0.1915. Do not forget to add the negative portion. We would have 0.5000. Adding them up, we have n of D sub 2, 0.6915. Using now the Black-Scholes model formula, V sub CO is equal to P times n of D sub 1 minus x e to the power of negative r sub rf times t times n of D sub 2. Substituting, we have V sub CO is equal to 20 times 0.7852 minus 17 times e to the power of negative 0.04 times 0.50 times 0.6915. We would have a V sub CO 4.18. That's right. The value of the call option is 4.18. 4.18 pesos is the amount that we are willing to pay if we want to buy this call option. Again, the very same principles of the binomial model are to be utilized here in the Black-Scholes model. They are the same. The difference is that while in the binomial model, we only consider two possibilities, that is, the stock price is high, stock price is low, and assign percentage weights representing the probability of occurrence. In the Black-Scholes model, we are going to assume a continuous distribution of possible outcomes rather than only two. Now, let us perform sensitivity analysis. What if we're going to tweak some of the figures? In the sample case, what if the stock price is currently at 21 pesos instead of 20 pesos? We are going to have the following calculations. This is the formula of D sub 1. If we're going to put the inputs, we would have the following. Therefore, D sub 1 is equal to 0.9592. The n of D sub 1 is 0.3315 plus 0.5, that's 0.8315. D sub 2 is equal to D sub 1 minus sigma times the square root of t. D sub 2 will be 0.9592 minus 0.4 times the square root of 0.50. D sub 2 is therefore 0.6764. Using the same Z table, we would find that this has an N of D sub 2, 0.2517, plus 0.5, that would be 0.7517. Going to the formula for the value of the call option, we have the following. Substituting the figures, we would have the following. If you are going to do this correctly, you're going to arrive at the V of the call option at 4.94. That's 4 pesos and 94 centavos. Note that if we're going to increase the current stock price from 20 to 21, the value of the call option will also increase. Well, this is actually intuitive. Naturally, if there would be a higher stock price, the more likely it is that the call option is exercisable and hence has a higher value. Now, I want you to perform sensitivity analysis as well. What if we're going to change the strike price, the risk-free rate of return, or the period of the option? You would be able to appreciate the interrelatedness of the variables in the Black-Scholes model. That would be all for this topic. Like, share, and subscribe.